So we're going to talk about hemodynamic formulas, the ones we've already covered from 140, the ones that you have done on your critical thinking assessment, the ones you're familiar with. We're just going to review those. You're going to have a couple questions on a Google, I guess Microsoft form. You need to answer those questions. That's your weekly activity. And then I will get notified that you answered those questions, and that will count for your weekly activity. So since we are doing this class online, I need you all to look at your syllabus and pay attention. Those weekly activities are going to be a portion of your grade along with assignments, and that's just to confirm that you are looking at the PowerPoints and reviewing the material and doing that. I would also highly recommend that you look at the schedule, and if you have questions on that, then let me know as well on that part. And then finally, Taylor, you get your wish. All exams, we're just going to do those at home. And so you can take them on Wednesdays. We'll still review for them so that like I'll post a review and I'll go over it just so I know you all are understanding the material, because we're going to talk about the hemodynamic waveforms, and we're going to talk about the formulas, and we're going to talk about how congenital heart disease and different things are affecting the heart and the hemodynamics and all that stuff. But I also want to talk about treatments of these things, and you all will be talking about that stuff in your 234 class as well. So we may overlap a little bit, me and Dr. Peterson, but just be aware that I want to focus on that too. So you're seeing it side by side and understanding, like here, if we see this, this is what we could do for treatment purposes. But today is mostly just a review. This is not going to be a long video. I will post the weekly activity is what we'll call it. And then you all do have an assignment, I believe, that is due. Don't forget, please, 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 to do your EVA quiz and your EVA signature sheet. Both of those things have to be done before next week, so get them done. I will also point out that you still have an extension on assignments if you need it. However, that will not apply to the weekly activity. The weekly activity is my assurance that you are doing the lessons each week. So they have to be done by Tuesday at 8 a.m. And everything will be available Tuesday at 8 a.m. I know the class is on Wednesday, but this kind of gives you like an day for the material to come out before the class. Since this is asynchronous, you all can kind of do it whenever you want. The exams will be timed, and they will only be available during that class period. So for exam days, you will have to be in Brightspace in those quizzes at that time. So let's get started with hemodynamic formula review. If you all have questions, obviously you can email or text me, and I can answer those for you happily. So this is what we're going to cover in the presentation today, just these different formulas. Once again, we're all should be pretty familiar with these. Ejection fraction isn't in this PowerPoint, and a lot of times we're doing that based off of the angiographic picture, the LV gram, if we do that, or they're getting it in the echo. So this angiographic cardiac output, we shouldn't be using this one unless it's like a last resort. We want to be using our FIC more so, but heart rate times stroke volume can give us a ballpark. But the FIC cardiac output is going to be our go-to, and it contains another formula, which is the AVO2 difference that we need to know, and that's listed down here at the bottom, so you all can see that again. We should once again be familiar, remember, with O2 consumption unless stated otherwise. For tests and everything, we're using 250 in that slot there. And then our FIC cardiac output, or cardiac output in general, is always liters per minute for the units. So then our oxygen content is going to be just our SAT times 1.36 times the hemoglobin. And then that's going to give us that oxygen content. The AVO2 difference is just finding the difference between the AO content and the PA content. So depending on what area we're looking at, so if we're doing the AO content, what SAT are we going to use? The AO SAT. If we're doing the PA content, what SAT are we going to use? The PA SAT. So whatever SAT, whatever area we're looking at, that's the SAT we're going to plug in up here. Our oxygen capacity is going to be the max amount of O2 that can bind to hemoglobin. And so that is going to be this down here. This number is kind of what we're looking at in a sense in right heart cath. And I was just talking to a doctor about this weekend. You know, why do we not want oxygen on when we're doing a right heart cath and we're taking SATs? And my answer was, well, because it affects your numbers. And that's all I knew. Like, hey, this affects my numbers. And he was like, yeah, but how does it affect your numbers? And I was like, it makes the blood more oxygenated. So, like, you're going to have a higher SAT than you actually should have. And he was like, well, but, like, how? And so then we started talking about only so much oxygen can bind to each blood cell, right? So only so much can get in the hemoglobin. So then where does that oxygen go once the max amount is bound in there? Well, it goes into the plasma. And so then he was saying that that's why we don't want to do it. And I was like, oh, nobody's ever told me that. I just knew it changed the numbers. So something that we do need to know. And then our fit cardiac output divided by our body surface area is going to give us our cardiac index. And so, oh, that should be fine. Sorry, guys. So we have to find the fit cardiac output before we can get our cardiac index. So, you know, steps through all of these formulas, they can tie into each other. And then we have our MAP and MPAP, and remember that we have to do 1/3 of the pulse pressure, and we find the pulse pressure by doing the systolic pressure minus the diastolic. So once again, it doesn't matter whether we're looking at AO pressure for MAP or are we looking at the PA pressure for MPAP. And so we're going to take the systolic of whichever pressure we're looking at and subtract the diastolic. Then we're going to multiply it by 1/3, and then we'll add the diastolic back in. For systemic vascular resistance, remember this is always in Wood's units, and this is going to be our formula. Once we do this part, the mean AO minus mean RA, divided by the fit cardiac output. So once again, vascular resistance is tying back to cardiac output. So what do we have to find first? Fit cardiac output. We are going to multiply our answer by 80, and that's going to give us the answer in the dynees over seconds, so dynees per seconds or whatever. But remember, you always have to multiply that answer by 80 to get your actual answer. And then the same for our pulmonary vascular resistance, but instead of our AO and RA, we're going to be doing our PA and our wedge. We're still multiplying by 80. We're still getting our dynees over seconds. And so those are the formulas that we're going to focus on for this next part, for your assignment, for the activity. Those are all going to be that. So for this semester, because I want us still to be involved in like thinking about things, we're going to do I say a group project, but you get to choose a partner. So we're going to do a partner project. Everybody can pair up. You can choose whoever you want, and you're going to choose, well, let me just go for it. I'll start talking, and then, so student presentations. We're going to do student presentations. We obviously do not have to do those in front of everybody because we're not going to be in class, but you are going to record them and send them to me, and then that is how I will grade them. And so those topics can be anything that we talk about this semester. So go back and look at the schedule, go through it. Or if you know of something else that you want to talk about that's hemodynamically or congenitally or anything that's related to what we're discussing this semester, but maybe we're not exactly covering that topic, you can email me or text me and be like, hey, can we do this? Great. That's cool. So you want to talk about the disease itself, and then you want to talk about the treatment for it and like so we're going to talk about what the disease looks like, how did they diagnose it, all those things, and then we're going to say, well, this is how they would treat it, or sometimes we can't completely treat things, but how we alleviate symptoms or whatever. So that's what you're going to talk about in the project. Like I said, you get one classmate to work with, and you all can work on this throughout the semester or last minute, whatever. It's due towards the end of the semester, so just be aware that that due date is going to be coming up. So your topic is due sooner. You have to get that sent to me. However, the actual project itself is not due till later, but I need to know what you're going to be talking about. And then for our final project, like I said, you're going to record it. You're going to send that to me. I want the video recording of you both doing the presentation together. And then I also want the presentation itself, whether it be PowerPoint or PDF form, emailed or to me. Well, I'll make a Brightspace Dropbox. So put it in the Dropbox. So I want both forms of it so that I can look at both. And then that is all I have for this first class. Syllabus, look over it, understand that there's no extensions on the weekly activity. Look when your assignments are due, and start thinking about ideas. So look at the schedule, think about what you might want to do for this class. And then if you have any questions, you just let me know. And so I will post this first, actually on the PowerPoint that I post for you all, I will have the link to the Microsoft Forms for you all to complete your weekly questions. And then, so you need to do the weekly questions, the EVA quiz, and the EVA signature thing, and get those turned in. And that is all. Once again, questions, let me know. It's your last semester. I know y'all are going to rock it. I'm super excited to see how everything goes and where everybody decides to go and all that stuff. If you all have questions about other stuff outside of this class, I'm here to support you all, and just shoot me a text and I will get back to you all as soon as I can. So it's going to be good. Clinical start, and y'all are going to knock it out of the park, and it's going to be great.